I would like to introduce today's presenters. Michael Jensen, Chief Research Officer, guides the practice's research agenda and architecture by leveraging his extensive experience to identify and unlock emerging trends. Akshat Vaid, Vice President, leads the engineering services research and advisory at Everest Group. He assists global enterprises on a variety of initiatives across engineering, technology, outsourcing, and ecosystem engagement. Mayank Maria, Practice Director, is a member of the engineering services team and assists clients on topics related to engineering spending and outsourcing across key verticals, including automotive, high-tech, industrial, and medical devices. Nishat Udapa is a senior analyst with Everest Group's engineering services practice, working across both custom research engagements as well as domain-intensive areas such as Industry 4.0, automotive engineering, and verification and validation engineering. And with that, I'd like to turn things over to Michael.
Hello, everybody. So when we were talking about the discussion item around digital engineering, I was immediately thinking of what that was supposed to mean. And when you think about digital, you think about IT, you think about computers, you think about programming. When you think about engineering, you're thinking about physical design, you think about things that are in the physical reality. And as we were talking about this, is really the digital engineering is where those two things come together. And it doesn't just apply to designing computer chips or bridges or buildings, but it really also goes into design and engineering of services organizations as well. So financial institutions, healthcare organizations, and really just about every industry you can think out there where the digital engineering landscape applies to. So we're going to go into some more detail around those definitions, and then we're going to talk about one of the key components of that, which is going to be the people or the talent. So we're going to talk about that because that's a critical aspect of it. And then, of course, we'll do Q&A. And as you have questions, certainly fill out the question and answer in the Zoom. We'll get to those along the way, or if we have to, we'll get to them at the end. But with that, let me do this. Akshat, I'm going to ask you to give us kind of a formal definition. I kind of gave you the casual definition, but what's your formal definition?
Thanks, Michael. And thanks everyone, by the way, for joining us for this very important topic of digital engineering. So let's start with defining digital engineering. So look, there are lots of definitions floating around. Some are suited to specific enterprise contexts around what is digital and what is engineering. Some are designed to fit a chosen portfolio of services, which is more the case with service providers. But we talk to a lot of people, and we have our own definition that we believe is sacrosanct enough for this particular domain. So what we have defined it as is leveraging a set of underlying digital themes to elevate experience and efficiency across product consumption, manufacturing, and engineering. So as you can see, there are three parts to this definition. There are digital themes, there is experience and efficiency, and then there is consumption, manufacturing, and engineering. So digital engineering is that effort which goes across the three functional areas of product creation, including consumption, manufacturing, and engineering. On the second level, it is to deliver the themes of experience and efficiency. And lastly, it leverages a variety of digital technology themes. Let's look at these closely in the next slide. So what you see on your screens now is you can call it the product creation value chain. It has three functional areas. The design of the product itself, the features, the use of digital technology to create smart, connected, and intelligent products is the first block of digital engineering. This leads to smart, connected, intelligent products, and we can call them connected ecosystems. It leads to personalized experience and also newer models of engaging with customers, right? The second block, so the product engineering, I would call, which is actually the third one that you see here, is the next area. So digital engineering in this part, it's about increasing the efficiency and efficacy of the processes through automation, as an example, or other digital technologies. The last bit here is the manufacturing processes. So the manufacture of the product, so where technology is used on the shop floor to create connected manufacturing to improve the equipment so that it becomes, predictable from maintenance standpoint, or enhance the connectivity on supply chains. All of these areas fall under the third block, which is the manufacturing processes, right? What you see at the bottom of the screen is the set of underlying digital themes, which I mentioned briefly on the previous page. So digital engineering invariably uses one or more of these themes. I want to highlight that these are not exhaustive by any means, and it's not to say that every single digital engineering use case would use all of these. So some permutation and combination of these automatically gets utilized in some of those use cases. The last thing I'd highlight here is the last block, the product engineering process block. So this is small, actually, if you look at it from the standpoint of the overall spend on digital engineering, but I want to emphasize that it's actually a very important one because it helps improve the overall engineering efficiency and efficacy. So with that, I think that's the definition. So let's now maybe look at how our audience perceives digital engineering with the survey on the next page.
Yeah, so with the definitions in mind that Akshat just gave us, let's get a view of what you think this does for your business. So how important is digital engineering to your industry and to your business? And going to ask you to choose one of these, and we'll see how those results come back here in just a few seconds. So we'll leave it open for another 5 seconds. Okay. So this is really slanted one way here when I look at the answers there. Okay, let's just go ahead and showcase the results here. And so everybody's certainly recognizing the importances here, the importance of this. It's a significant impact is almost all the answers are sitting there. It's without it, a couple of people are saying without it, we're out of business, but almost nobody is saying it's less relevant.
It's not important. Yeah.
That's not important.
Yeah. Absolutely. There's no debate on this slide. I think most people are recognizing that it's either mission critical for them or digital engineering is something that is really having a significant impact on products and the end customer experience as well. I think if we had an option on digital engineering improving operational efficiencies, which Akshat spoke on the last slide, I think that would be another option that would get a lot of votes as well. But this kind of illustrates the fact as to how important digital engineering is. There are, I think, couple of people who've chosen the last option, which is they're not really aware of the business case at this point. And I think that's a fair call. And another reason as to why people might have chosen that is there's always some confusion between traditional and digital engineering, right? There is some kind of an overlap between that. And if you actually go to the next slide, that's where we're trying to compare and contrast traditional and digital engineering. Yeah. So traditional engineering has always been there. It's something, it's essentially the physical building up of products. And digital engineering, we're not saying it's a replacement for traditional engineering. And in most cases, you'll actually see that digital engineering works in tandem with, and it augments traditional engineering in order to either improve products, to provide a seamless customer experience to the end users, or to improve operational efficiencies for enterprises, right? And to sort of illustrate this point further, I can probably take a couple of examples across each of the three themes that Akshat spoke about a couple of slides back, which is product, manufacturing, and engineering processes, to sort of describe how digital engineering acts on top of traditional and then leads to improvement in processes and products as well, right? So let's take a simple example. Let's say we're talking about designing and building out an automobile, right? So on the product side, you will still have to do, carry out all your traditional work streams. You'll still have to mechanically design and test those products. You will have to design and test your integrated circuits, PCB boards, etc. And it is on top of that basic underlying components that, you have your digital overlay. So you add connectivity elements on top of it. You start gathering data in terms of what are the features that people are using. And then you sort of perform your analytics on top of it to understand customer preferences and then improve end consumer experience, right? Similarly, on the manufacturing side as well, you would have all the factory floor operations which are going on. You would have all your operational technologies, the likes of SCADA, PLM, MES, etc., running, which are essentially your operational technologies. But now what's happening with the augment of digital engineering is there is an IT angle as well attached to it. So there is a lot of IT, OT integration that's taking place. We are seeing smart factories coming up. We are seeing Industry 4.0 gaining a lot of prominence. A lot of technologies like additive manufacturing, digital twins, simulation, etc., are now coming to the shop floor. And this is essentially the industrial IoT or industrial Internet of Things, bandwagon that we're seeing now. And finally, of course, the engineering process bit, which again, Akshat spoke about as to increasing operational efficiencies. I think this is one area where probably digital engineering has started to slowly replace some of the traditional engineering bits. If you look at the couple of examples we've mentioned there around product teardowns and technical documentations, there are plenty of digital engineering technologies out there, things like automation, robots, simulation, using extended reality, etc., which can start to slowly replace some of the engineering processes. But where we are currently is traditional is still very important. It's still a larger slice of the pie, although digital is, of course, gaining in prominence. So, what I've done.
Let me just jump in there real quick. So what you're saying here is none of the things on the left are really obsolete. They're not going away by themselves. Really, what you're saying is the digital engineering talent or skills that you're talking about here really are accelerants to the overall trend here.
Absolutely. I think I would 100% agree with that. So traditional engineering is not going anywhere, at least not in the near future. So as I said, on the product engineering piece and the manufacturing engineering pieces, digital is really augmenting and adding to what traditional engineering is doing. It's only on the engineering process side that we could probably see over the next 5 to 10 years that digital starts replacing some of the traditional activities. But I think as of now, we're still a long way away from that.
Yeah.
All right. So I think so far we've spoken a lot about examples across some of these three themes, but digital engineering really has a very rich vertical flavor to it, which I think Mayank is going to talk about on the next one.
Yes. Thanks, Nishant. So while digital engineering is witnessing varied adoption across verticals, the point is that it is all pervasive, right? We've taken some examples of use cases across 8 or 9 verticals that we see playing out, but there are so many other verticals as well, and digital engineering, holds its own relevance there too. Again, if you look at product-centric verticals, verticals that actually bring out and sell physical products, let me take an example of how digital engineering is gaining precedence. So in the medical devices space, if we talk about software as a medical device, right? It's a fairly recent trend, which is actually enabling the medical devices companies to offer a standalone software, that doesn't need any special purpose hardware, and this software can serve as a medical device. So what that means is, the whole versatility or interoperability, even the level of personalization that can be offered in a medical device, because it's only software, that has gone much higher than what it would have been had it been coupled with the hardware or been a special purpose hardware, so to say. Similar examples across all the product-centric industries, we see them playing out. But another important point that I want to make here is around services-centric industries. If you look at industries like banking, like healthcare, like insurance, right? Here, the service delivery platforms or the platforms that are being leveraged to interact with customers to actually deliver some services to the customers. The kind of personalization, customization required there, that's all possible because of digital engineering. And organizations often confuse it or place these customer-facing portals or platforms under IT. But the kind of rigor, the kind of availability required for such platforms, that's not possible without actually bringing in the domain or the mindset that engineering has to offer. So net point being, digital engineering is very relevant, be it product-centric industries or services-centric industries. Next, on the next page, if we look at, how digital engineering is panning out in terms of the size or the relevance it holds in the global scheme of things. So we estimated in 2020 the overall engineering spending by businesses, it stood at around $920 billion, and nearly 24% of that was held by digital engineering teams. So, you saw some examples of how digital engineering is manifesting, right? All of that translates to nearly 24% of the overall spending share for digital engineering. Some of the other observations here. So we see that digital engineering growth, it has been far higher than some of the traditional pieces, right? If you look at the historical years and even the forecast that we have for 2023, right? Digital engineering will continue to grow at a much faster pace, and what it will lead to is holding nearly 28 to 30% share in the overall business engineering spending fairly soon by 2023. One more interesting observation here, if we look at the year 2020, when COVID-19 hit us, so digital engineering, in fact, continued to grow, although at a slower pace of 4.5 to 5%. But that's still commendable when we look at the traditional pieces that we saw contract by around 7% as enterprises went into a recessionary mindset.
So Mayank, these are really big numbers measured in trillions. I mean, if you look at those numbers there, the enterprises are spending out there. How does this intersect with the outsourcing industry?
So Michael, this trend is actually getting replicated for the outsourcing world as well. So if you look at overall outsourcing in the engineering world, it stands at about $50 billion. I would say around 15% of that is coming from the digital engineering teams. It's slightly lower than what the enterprises are expending, in terms of proportions, but it will also grow and catch up as enterprises go towards more scaled initiatives, even outsourcing, and the share of digital engineering in outsourcing that will grow significantly.
I think one thing, Michael, which is perhaps important to highlight here is, if you look at the outsourcing spend and the way it's structured between traditional and digital, the digital engineering spend, even on the outsourcing bit, is growing way faster than the traditional one. So maybe from the perspective of a service provider, the area of digital engineering is one to invest further and seek a lot of growth in.
Yeah, makes sense.
Agreed. Kiara, if you could move to the next page, I want to make some more observations on what went down in 2020 and why we actually witnessed a growth for digital engineering, while at an overall level or for traditional engineering there was a decline. So essentially, we did study some of the enterprise investments, use cases, etc. And what we concluded was that there were two key drivers for enterprises to continue investing in digital engineering. On one side, they realized that, given the lockdowns, the restrictions, the whole remote models, that started taking place in 2020, there was a need to, still deliver robust, personalized experiences to the end customers. And for that, we saw enterprises across verticals, be it a vertical like automotive, be it a vertical like telecom, invest in these service delivery platforms, either from scratch or enrich them if they already had them, in a way that, more use cases could be serviced through them. There could be more features that could be offered to the customers. That's one part of the story. The other part of the story, it's more on the operational side. So, again, we saw challenges as to how enterprises had to manage their manufacturing with limited staff. There were these social distancing norms, etc. Right? And then even the supply chains, they were getting disrupted. So on this operations side also, enterprises felt that there is so much need to invest in digital engineering so that the overall resilience of these operations can be enhanced. So again, a variety of investments, be it on the shop floor itself or be it on some of the processes that feed into the shop floor, we saw so many digital engineering themes and investments. And that's more about the past. This whole pandemic, this has led to a bit of a shift in how enterprises are actually looking at digital engineering. And we believe, this thinking is going to continue into the near future as well. I'm going to invite Akshat to give a bit of a view of what we expect in the near future.
Yeah. Thanks, Mike. So I'll pick up a bit of a pace and not spend too much of time on the next page. So on this page, the point I'm really trying to drive is the adoption of digital is not homogeneous across use cases, and it is tied to the fact that the ROI across use cases is also not homogeneous. So it's kind of, it kind of goes hand in hand. And what COVID has done is it has led to a clearer mandate for or against investments, depending on whether the investment would lead to a substantial benefit and soon enough or not. And this chart kind of shows that. So what you see here is two axes. One is on the level of impact of the use case, to what extent that use case really provides the benefit that it is supposed to provide. And second, what is the payback period? So this example is actually of the smart factory space, and each of the dots and the associated text that you see here is a specific use case in that space. So what you see here is the spread, and the bottom right area is essentially the section of use cases where we are seeing a lot of investment, because the level of impact is higher and the time frame in which the impact is observed is lower. So we can take a couple of examples. So ecosystems pertaining to connected shop floor. So as an example, the predictive maintenance of equipment use case or the asset monitoring one, they tend to cause high amount of cost savings through downtime reduction or remote operations. And they have high adoption as well as high ROI. So low payback, hence they are here. Cybersecurity is another area. So cybersecurity risks are increasing manifold, and the high cost associated with cyber attacks is leading to an increased usage of the security measures. So high impact as well as high savings. Hence, this features here. In contrast, so blockchain related use cases or additive manufacturing, they are still emerging and the impact is also limited. So hence, they don't quite feature high on the investment priority, right? So in general, what we are really trying to convey here is that enterprises are advised to follow this kind of thinking, wherein on one side they're evaluating the level of impact, on the other the payback period, as they go down the path of investing into digital, especially in the times of COVID when cash is not easy to come by. Right. So next we take a look at some of the challenges associated with digital engineering. No shortage of those, to be honest, but some of these are more important than the others. So let's find those out. Michael?
Yeah, so let's get your thoughts on this. We're going to ask you the question here for a quick poll. What are the challenges associated with adoption of digital engineering from your perspective? So we're going to open that up, and we've got number of challenges for you to go ahead and make some decision choices around. All right. Okay, we're going to go slanted to hard to one answer. Looks like it's going to be not much of a horse race here. Got one answer running away with it. All right, we'll leave it up for 5, 4, 3, 2, last chance. Okay, all right, let's go ahead and close it out. And it's a good thing that we have the next section of our slides are going to be focused in on the talent. So accessing talent is the runaway favorite here.
Yeah, and the last one, which is finding the right technology and services partners, we do briefly address that too somewhere. So good results. Let's move on.
A common theme across a lot of the client conversations recently has been talent, and it's a question of it's the scarcity, and it's also the rising prices for people. I think that's really where it's coming down to. And so let's dive into that detail right now.
Yep, let me come in here, Michael. In fact, I think as the poll suggested, and as most of the audience clearly seems to think, talent is really the biggest challenge out there for organizations to, get into the digital engineering journey. And in fact, the slide here and some of the stories here from leading enterprises across industries sort of corroborates that view, right? So enterprises have started to view talent as a key enabler of their success as they embark on their digital engineering journey. And we just have a few examples of leading enterprises from industries as varied as semiconductors, consumer electronics, Schneider Electric from the manufacturing world, the likes of Google and Amazon, which are the leading internet companies as well, right? And if you look at the write-ups, all of these are essentially talking about the same three things, right? Number one, they need to identify and attract the right talent if they want to succeed in the digital engineering world. Secondly, they need to be able to retain that talent. So that, of course, involves a lot of investment in terms of both identifying, attracting, and then retaining the right talent. And third, of course, you need continuous investment to keep on upskilling the talent that you do have, right? So that's essentially the reason why a lot of these top enterprises have started to look at talent as a key enabler of success. And in fact, it's also critical for a lot of other organizations as well to recognize the nuances behind hunting for digital engineering talent. And I think that is something that Akshat is going to touch upon as we move on to the next slide.
Yeah. So thanks, Nishant. So see, talent is a critical piece, right? We could see it on the previous page. All of those big logos are acknowledging its importance from a digital engineering standpoint. And at the same time, it's a key pain point as well. And we'll talk more about that in the coming slides. Right, so we're actually looking at it from 4 angles. So the first one is around the fact that the shortage of digital engineering talent is very steep. And if you're looking at digital as a differentiator for you from a product and customer experience standpoint, you will have to fight a war of talent, right? The next one, quite invariably linked to the shortage, is the fact that you will have to pay a premium. It will invariably lead to the increase in price of this talent, and you'll have to deal with it. Thirdly, again, quite in continuation, if there is shortage, you need to double down on your procurement strategy, and you have to have a well-rounded one put in place to ensure that the sustained supply is available for all your needs. And lastly, choosing the right locations will be critical. So it's linked to your procurement strategy, but we've identified a lot of hotspots across the globe, and your location strategy kind of needs to go in sync with that. So let's start with the first one, which is around shortage.
Yeah, let me come in here. If you can move to the next page, please. Right. So, as part of our research, we've done a very thorough analysis of the global ER&D talent. So, we did a bottom-up analysis, studying various capability areas, various talent or skill pools, right? And based on that, what we conclude is that in 2019, if we look at the overall ER&D talent pool, the demand, which is the lighter blue shade that you see across these graphs, it exceeded the supply, which is the darker blue bars, right? In 2019, if we look at the overall ER&D talent pool, the demand exceeded the supply by nearly 300,000 FTEs, right? Which is huge, right? And if we get into the specifics of the emerging skills or the digital engineering skills, the picture in terms of what percentage of the demand stays unfulfilled, that's even more grave. So if you look at the chart on the right, the number 0.7 million, that's the demand for digital engineering skills in 2019 against a supply of only 0.6 million. So that translates into a demand supply gap of nearly 14%, as opposed to looking at the overall pool, these gap is just about 5%. And what's even crucial is to look at the future. So if you look at the overall ER&D talent pool, again, the supply demand dynamics, they will get even worse in the next 1 odd year. So the demand will exceed the supply by nearly 0.9 million FTEs. But what's interesting to note here is that most of this excess in demand, right, and this mismatch between demand and supply, this is going to come from the emerging skills or digital engineering skills, which will account for nearly 700,000 FTEs worth of unmet demand. So, what we are alluding to is that this need for talent and this war for talent, it is only going to intensify in the near future. And what is needed is a very solid strategy to kind of procure this talent, retain this talent, train this talent so that an enterprise can be successful.
So how does this play out here? I mean, it looks like do we not have enough graduates? Are the graduates going down, or we just don't have enough of them? Is it we're looking in the wrong locations? I mean, do we need to have more kids, have more babies and kids so it can help resolve this over the long term, or what's the deal here? How do we fix this?
So, Michael, in my opinion, 2 or 3 reasons that are contributing to such a gap. One, of course, is these emerging skills or digital engineering skills. Their adoption is really picking up, and the supply is not able to keep pace. Why that's happening is, one, if you look at our education system, right, the curriculum is still not rightly aligned to the demand of the industry. So, the graduates are not readily deployable. They have to be retrained, upskilled before they can actually start working on projects. Right? If organizations look internally, what we found is there is so much inertia for them to kind of upskill some of the talent, that's available in-house, but for more redundant skills, that is not happening, and hence, this gap continues to exist.
I think at the base of it, Michael, it has to do with the speed with which the demand for these skills has grown, right? And supply hasn't really caught up to that. Foundationally, it is that, right? If it happens over a period of time, supply adjusts according to the demand, courses get added up, more people get interested, they get skilled, and hence, there's a sustenance of that pool. But in this particular case, over the last half a decade or so, very suddenly the amount of demand per se has really just skyrocketed. That's why what you see on the 2022 graph, right, for the emerging skills, the gap is going to widen all the more, right? And there is absolutely no practical way in which you can fill that.
Yeah, ultimately it'll be a follow the money conversation. As the salaries rise here, people will look at it and say, well, that's a very good jobs and good paying jobs. Ultimately, that will probably be the thing that tips the balance of the supply demand equation.
Very true. Just that it's going to take its own sweet time. Even in an accelerated manner, I don't see that getting adjusted for another maybe 5 years.
Yeah, it takes a while.
Right. Let's keep the conversation going. If we move on, so a quick glimpse of results from a survey that we had done with some of the enterprises. Right. Most of them, they reckon with the fact that this talent shortage is causing serious concerns for them. It is a key barrier for them to achieve some of the outcomes, business outcomes, right? And what are the kinds of challenges? One, we already talked about, the supply is short, right? If the enterprises go out in the market, they're not able to find the qualified talent. The internal talent, the talent that they've hired, also they have to invest to kind of make them technically sound. So that still stays as a challenge. Other interesting things, project readiness of talent. So even if the talent comes in with the digital engineering skills, the domain seems to be lacking, and hence again there is a bit of a gap in the talent being project ready. And the last one, attrition is a big challenge. The enterprises in some of the more traditional engineering verticals, they are now competing for the same talent with some of the high-tech enterprises who are more favorable, more favored employers. So in that sense, even attrition tends to be high. So a variety of challenges that the enterprises are grappling with. Let's go deeper into one aspect, that is the talent demand and supply scenario across some specific hot skills. How does it look like? So let me invite my friend Nishant to talk about that.
Yeah, thanks, Mayank. Let's go deeper into the talent scarcity that exists across some of these digital engineering skill sets, right? And as Mayank spoke, the demand supply shortage is really huge on the emerging skill set side of the story. So if you look at the chart, the x-axis here essentially represents the level of adoption of some of these technologies, and the y-axis is essentially talent shortage, right? So a lot of these technologies vary in terms of their maturity. So there are technologies like cloud engineering, AI, ML, IoT, analytics, etc., which are fairly ahead in terms of their adoption curve or in terms of their maturity, right? And yet there is a significant talent shortage that exists for each of these individual skill sets, right? What's more interesting here is, a lot of these technologies actually follow the trend line, the dotted line that you see in terms of the talent shortage that exists. So as maturity or adoption increases, talent shortage also increases, but that's happening more or less, on a linear scale. What's more interesting or troubling is if you look at skill sets or technologies around 5G and cybersecurity, right? These are two technologies where the current levels of adoption is fairly low, or at least relatively low if we compare it to the likes of cloud engineering or AI/ML. And yet we see that talent shortage is already significant in these two technologies, right? So, do expect a fairly big talent war when it comes to sourcing talent for some of these two emerging skill sets. Going to the next slide now, I'll talk about, this sort of, again, just corroborates some of the findings on the previous slide. So if you look at individual skill sets within containers, that is cloud engineering, edge analytics, data analytics, AI, ML, IoT, across all of these, right, you see that there is significant talent shortages when we look at the individual skill sets that sort of come together to make up this technology. And that is really issue number one for enterprises, right? There is no talent available out there that they can actually go out and hire. The other big challenge for enterprises, and this is probably the more critical one, is that even if enterprises do find talent that has certain skill sets, they are not immediately deployable. And the main reason for that is that engineering is significantly different to IT in the sense that there is a lot of domain know-how or domain expertise that is required. And until and unless resources have that domain know-how, they can't really contribute to engineering work streams. So the survey that Mayank alluded to earlier, another interesting result from that, 75% of enterprises indicated that they are finding it difficult to find cross-functional talent. Essentially, people who have the required domain expertise, they have an understanding of the platform that they need to work upon, and they have expertise in certain skill sets that have been mentioned on the slide. Right. So these are the two really big challenges that are facing organizations, and the primary reasons as to why there is such a big talent scarcity out there. And the natural consequence of this is also being seen now in the pricing world, which Mayank is going to talk about on the next one.
Actually, let me take that instead. Thanks, Nishant. So let's talk pricing, right? And to put it bluntly, in digital, be absolutely ready to pay more, right? Compared to traditional skills, digital skills for the foreseeable future will command a decent premium, right? And what you see on the chart here is essentially that. So the three towers, the base one is traditional engineering. These are for skill sets such as legacy software or other engineering skills such as mechanical engineering, CAD, CAM, and so on and so forth, right? Now, if you compare this to the other two, you can see that there is a significant premium for the first set, and I'll in a moment explain what that set is. For the first set, you're going to pay about 15 to 20% more, and for the next one, it's a 5 to 10% bump even on top of that. So, what are these two segments? So, the first one, the one in the middle, these are areas which I would say are the high adoption digital tech segments, right? The higher demand has led to a relative better supply and hence moderately high premium. So areas such as cloud engineering, in some ways you can also observe that these are evolutionary in nature. A lot of traditional engineering and computing domains have evolved into these areas. So cloud engineering, analytics, microservices, these are important. There is definite shortage, but not as much as the last one, and I'll come to that in a little bit, right? So in these areas, the higher demand over a period of time has led to a decent supply, whereas still some shortage. So here you have to pay some premium. The second segment, the niche emerging skill set segment, right? These are altogether new domains in computing technology. We call these exponential tech. So these are not as mainstream, somewhat niche. Hence, the skill pool is also small. So even though the demand is relatively less in absolute numbers, the percentage shortage is high, and hence the price premium is also significantly high. The last thing I'd mention here is that these are ranges. They vary based on a lot of factors, but one of the key ones is onshore versus offshore. So the premium onshore tends to be even higher. So whatever is the ongoing price for traditional skill, the digital skill onshore will be closer to in the first, or rather the middle box, will be close to 20% higher, whereas offshore it will be closer to 15% higher. Yeah, so this is on pricing. Let's keep going. So the next one is on procurement, right? So the other linked area. So while there is shortage, while there is price premium, as an enterprise looking to ensure that you have a healthy supply, you got to look at procurement in a fairly holistic manner, right? So you got to look both inside as well as outside. So on the inside, you first of all have no other option but to reskill and upskill the existing workforce. The key benefit here is that more often than not, these people will end up becoming more productive than what you hire from the outside, because they bring the domain along with them, right? Whereas what you hire from the outside, you can never really be sure in terms of how well would they understand your specific industry and domain, right? The second bit is about retaining and rewarding. So like we said earlier, there's a price premium, hence jumping ship is not something which is uncommon at all. So retaining talent through rewards, recognition, and in general higher salaries is something that you will have to look at. And other aspects such as talent analytics to conduct the skill gap analysis in advance and uncover shortages around those areas. Those are all the things that you'll need to do. On the outside, I think it's fairly clear that you have to look at outsourcing partners, especially when you need a ready scale, right? Hiring a few incremental resources is easy, but holistically looking at hiring a significant block, more or less partners is the only answer. The second one is using offshore locations and resources. So not just through the partners, but even looking at your own captive centers in other geographies, that could tend to be fairly useful. And last thing that I would cover here is that of academia. We've seen some successes here. Both enterprises as well as service providers have partnered with universities and academy out there to ensure that there is a certain connect at that level itself. And when those skilled resources graduate, they have a natural gravity to come and work with you. Examples such as SoftServe on the service provider side is a great one, right? They have a very good model where this kind of an association leads to a rather healthy supply of talent for them. So yeah, that's from this the standpoint of procuring talent. Let's keep going. Let's move on to the next one.
So one of the best things, Akshat and Mayank and you guys practices, I know, has been growing at an incredible pace alongside the actually faster than the growth rates of the industry. But one of the best things that you guys can do to talk to help clients understand what you guys do is just to have that conversation. So we have not gone into details around any specific vendors in this webinar. But if you're interested in a conversation with Akshat and his team, giving you an opportunity here to click the button and have that conversation about either vendors or your peers in the industry, go ahead and click that organization that you're most interested in knowing more about. And Akshat and his team will be in touch with you to talk about some more details about that organization. So I'll leave this open for another 5 seconds. I know you guys have some really interesting client conversations, so I know this always helps kind of boost those the number of those. So all right, let's close it out and we'll go from there. Okay, so let's take this into the next aspect, Mayank, if you would, and talk about some of the industry participants.
Right. So I think I'm moving forward with what Akshat already alluded to, and one point that I want to touch upon here is that enterprises essentially, need to go beyond geographical boundaries, even organizational boundaries, to procure digital engineering talent. And there are some interesting models that have popped up in the recent past, which would actually help them do that. So be it gig economy, that is, procuring talent via some gig platforms. And, these platforms tend to be very rich sources of digital engineering talent, given the millennial workforce and their preference to, have that kind of an independence of working when they want to, right? Uh, Contingent workers, accessing talent via some of the staffing firms, and the benefit here is, anytime kind of a scale up or scale down. So what it helps is, it helps you access talent when you need it, and it helps you save costs when you don't, right? And the third one, building a satellite workforce. So even tapping into some of the locations or cities that do not have huge sizes of digital engineering workforce, but you also set up smaller centers there and tap into the resources from there, right? These are some of the interesting models that we've seen coming up, and again, we believe that they will gain much more precedence in the enterprise talent conversations, talent strategy going forward. Of course, there are some things that we need to be careful about when tapping into these models. Things like governance, things like making sure that this remote talent gets tightly integrated into the overall workforce in some ways, right? Uh, Taking care of IP protection very robustly. These are some of the ways or some of the things that need to be taken care of. But point being that we still need to tap into these new models. And I think driving forward the point around going beyond organizational boundaries, going across geographies to procure talent, I'm going to invite Nishant to talk about some of the leading locations that we are seeing emerge for digital engineering talent.
Yeah, thanks, Mayank. Right, so we believe that, given the huge talent scarcity that exists in the market, given that a lot of digital engineering talent actually commands a price premium, we do believe that, organizations need to identify the right locations that they need to go to and look at talent. It doesn't really make sense to go to Africa or to some of these offshore locations to find the highest quality of digital engineering talent, right? So this map essentially indicates where digital engineering talent is located. So there are offshore locations like India and China, yes, which have a lot of talent pool given the size of the population. But the cutting edge and really innovative digital engineering work is really happening in the onshore locations. So the US, in North America, Western European countries, Japan, these are the places where the quality of digital engineering talent is really high. And also, of course, these are also the locations which can actually afford, to pay the premium for some of this talent, right? So these are the locations which are actually the hubs for digital engineering talent currently, and these are the mature locations. What's more interesting though is if you look at the next slide where we are capturing some of the emerging locations out there, you'll see that organizations have started to look at a lot of the nearshore locations as talent hubs, right? So nearshore North America, which is Latin America, so countries like Mexico, Costa Rica, Colombia, these are the countries where there's a lot of emerging talent around cloud engineering, analytics, AI, ML. Similarly, nearshore Europe, which would be countries like Ukraine, Romania, Poland, etc. Again, very similar skill sets to LATAM, a lot of design engineering, product engineering work actually taking place out of here. And more recently, we've also seen a location like Vietnam, which has started to really gain in prominence, especially for skill sets around semiconductor engineering, consumer electronics, and so on, right? Right, so this was around locations. I think we've spoken a fair bit on talent, which is really the critical enabler for enterprises or organizations who want to go down the digital engineering route. I'll now hand it over to Akshat to talk about the other key enabler in this piece, which is essentially the role of the ecosystem.
Thanks, Nishant. So, last couple of slides, before we conclude the session today. So this is actually a different aspect. It's linked to talent because in many ways you can look at these ecosystem entities that you see on your screen for support in variety of ways. But I think even as a standalone point, this is very important. Look, digital engineering rather is not something that as an enterprise, most likely you will be able to achieve on your own. You definitely have to look outwards, right? There are a variety of different ecosystem entities that serve different needs. We have illustrated some of those here. There are many others, but just to name a few, the first one is cloud vendors. So all of us understand the nature of the digital engineering workloads and use cases. Invariably, platforms are a part of it, and hence cloud vendors typically tend to play a very critical role. They also provide solutions. They also provide scaling prowess. So all of those things are important. Hence, associating with them makes a lot of sense. The second one is chips and sensors vendor. So again, connected products, connected equipment. All these devices, modern devices these days are mini computers in themselves. Chips and sensors invariably are a part of the product. Hence, partnering with them for your next generation of products is important. Third category is that of startups and niche players. In many occasions, you would find them not as critical, but in some they can tend to be important, where they are providing certain cutting edge solutions which are not a part of the product suites of some of the leading technology providers in your industry verticals. And lastly, if you look at service providers, we mentioned earlier as well, they can provide support end to end across the value chain of engineering, manufacturing, and product consumption that we spoke about. So from that standpoint, for talent, for scale, for IP, and for having a partner who could work with you to go on the journey, service providers tend to be very critical. Obviously, you got to be mindful of a lot of things when you do that. These are in general applicable to anything related to engineering, but in digital, all the areas such as data security, quality assurance, protection of your IP, these become really important.
So Akshat, this really, whenever I look at a slide like this, and we do it for other areas as well, but I always want to ask the question around follow the money. Who's making the big investments? Who has the money to take this the farthest?
Yeah, interesting question, Michael. So actually, if you look at this landscape, at least within the four segments that I've highlighted, all of them are spending money in one way or the other. Some for capability, some for scale. But I think holistically, it's the cloud vendors. By far, they are the most critical piece in this equation. They have huge partner ecosystems. They are investing a ton of money in building vertical specific cloud platforms. They are investing money in the vertical specific solutions that work on their platform. And in many cases, they are even happy to provide a lot of support from a workforce and professional services standpoint as well, right? So they are incomparable in that sense, right? I'm not discounting the position of any of the others, right? But I think cloud vendors stand apart.
That's been a common refrain across several of these different conversations. And there is we did a session where we talked about the cloud vendors, and make sure you protect yourself there though. So it's not a free conversation. It can eventually be a very expensive conversation. So, all right, let's go ahead and bring this home. What are your concluding thoughts here? What do you want to have our viewers think about?
Yeah, look, without having to read these, from the slide, I think, look, digital engineering is not, something of a choice anymore. You can't choose to not participate in this transformation. You have to invest as an enterprise who's looking to sustain its place in the competitive marketplace. You have to invest in digital, and there are lots of components that would go into it. The most critical one that we talked about today is talent, and there is a severe shortage. It's almost pretty much a little war out there to get the best of talent at the required scale. So if you got to sustain that, you definitely need to work on your procurement models. You definitely need to look at emerging locations. You definitely need to partner when and where it makes sense, right? And at the last point, related to what I just said, even in general, to sustain yourself in this market, to accelerate and ensure that your time to market expectations are met, you got to look at the ecosystem of partners that could work along with you. It's definitely not a job that you can do standalone.
Yeah, and my biggest takeaway from this whole conversation is it's digital engineering. It's not for just the goods producing manufacturing sector. It applies to all the industries, including the services, and so as you think about that, how that applies to the talent is going to be able to be mobile across those different segments. And so, you know, you're competing with a whole new set of players that you may not have thought about before in terms of getting these people into your teams. Okay, so we're going to open up the question and answer. We got just a few minutes here. Before we do that, Akshat, tell us how you work with clients, just in 60 seconds.
Yeah. So look, we are a research organization. We are an analyst organization focused on 2 or 3 different domains. One of those is engineering services. I'm talking as an organization at Everest Group. Within engineering, we are fairly wide as well as deep. You would see us working across industries which are important in the engineering world, as well as across horizontals such as software engineering, digital engineering, industry 4.0, and so on. What we do is we publish a lot of research which is important and covers the important areas such as locations, talent, service provider landscape, and then we also provide bespoke support on a variety of different areas. Our support is available to all the 3 different ecosystem entities. So, first is enterprises. If you're looking to outsource, if you're looking to understand this ecosystem in a greater detail to ensure that your sourcing strategies align, we can be of help. If you're a service provider and you're dealing with problems around strategy, differentiation, or growth, we could support you. And lastly, other ecosystem entities, whether you are an industry body or looking to invest in this space, you could reach us and we'll be able to help.
Okay, certainly doing some really good work out there with your team. Let me take it to the first question here, and really focusing in on that talent slide back there. Kira, if you could go back to slide, just on the fly here, go back to slide 20. We talked about the skills premium here, and you made a couple different points. These numbers are ranges. They can go up, especially for the onshore. But the question here is around the skills premium, and does it stay there forever, or is there areas where the skills premium goes away? Because that's one of the questions I've seen in the different areas where you get hot talent, it gets pumped up, and does it ever go away? Is there ever the not so hot talent that goes down in premium?
Yeah, no, that's a very important point. Look, as far as I remember, what I said on this slide was this premium is going to be there for the foreseeable future, and I think I'll stay with that. So this is definitely not permanent. There is nothing permanent as such in any domain whatsoever, but the respite from the premium is not visible over the next 3 to 5 years, perhaps, at least not so soon. Few other point, whether some of the skills have seen reduction in the premium, etc. I would say not, that already hasn't happened. But if you look at some of the other examples, so front end development, automation, data science, although all of these skill sets still command a premium, but the quantum has toned down somewhat, right? Because there is relatively decent talent availability. In some of these areas, we still see maybe some service providers opportunistically charging a premium, but at a broader level, it has diminished somewhat. I think the same rule is going to apply here as well, as some of these skills see more supply, which will happen, of course. People will realize the demand and the price premium, even the salary premium that is available. We will see supply kind of catch up with the demand, and as that happens, the premium will go down.
Okay, yeah, and I just think in this particular area, it's going to take a while. So, all right, well, we're out of time. We're going to get some of these questions that we didn't get to. We'll try to respond to those individually. You've got our email addresses in the presentation. The presentation will be delivered to you in short order. There's a number of related content up on the website, and certainly if there's anything we can do to help you, let us know, and we appreciate your time.